Okay, let's start working on this one. I'm looking for a quadratic function that passes through these points, right? When x is equal to 0, y is supposed to be minus 3. When x is equal to 3, I get a 0. And when x is equal to 4, the quadratic function is supposed to give me a 5. So let's start with where the only thing that we know, right? I'm looking for a quadratic function. So let's give it a name, f of x. And because it's a quadratic function, I know that it's going to look like ax squared plus bx plus c, right? That's every single quadratic function looks like that. Now, I've got a couple of points here, right? I've got 3 points to use. And I'm going to start with this one. And I'm going to start with this one. You don't have to do this. You could use any point in any order. And then, right, you have 3 points here, and you've got three unknowns here, A, B, and C. So you could combine all that information and give yourself a couple different equations and solve for your A, your B, and your C. But we can be smart about this. Let's look at this point right here, the second point. I know that 3 goes to 0. So in other words, I know that when x is equal to 3, that gives me a root of this equation. Right? So when x is equal to 0, sorry, the function gives me a 0 when x is equal to 3. Well, that means that x minus 3 is a factor of this quadratic function, right? I know that it's x minus 3 times something else, right? Because I know that 3 is a root, I know that x minus 3 is a factor, right? I could have something else. In fact, I know that I do have something else. This q of x is going to be another straight line that's going to have 1x in it because I've got 1x there. That one will give me the 2 that I need, right? But with this in mind, let's try to figure this out. So the picture right now looks something like this. I know I crossed there, and I don't know how I do it, right? I could touch once and bounce back, right? That 3 could appear as a 0 or x minus 3 as a factor twice. And it could have positive coefficient or it could have negative coefficient. It could be concave down like that. Or I could pass through that root and then pass through another one. But in either case, I know that I'm going to have x minus some other unknown number. So I don't want to use a, b, or c because those are already spoken for. So let's use d. Right, d is just some other number. I know that this function is going to have another root. It might be 3 again, or it might be some other number. Okay. Now, one thing that I also know is that this function could be dilated by some factor. So I don't want to choose a. Let's choose e because e is unspoken for. So I know that my function is going to look something like this. And we have successfully used this information that 3 gives you a 0. All right, let's try to find these two missing constants, right? I don't know what e is. I don't know what d is. So let's go to one of our points. Let's use the fact that 0 gets mapped to minus 3. So minus 3 is the output of this function at 0. So that would be e times 0 minus 3 times 0 minus d, or e times minus 3 times minus d, or 3ed, right? That's supposed to be equal to minus 3. And I can simplify this just a little bit further. Minus 1 is equal to e times d. Now, I don't know what e or d is, so this is really as far as I can go. All right, let's use this other point. 4 gets mapped to 5. So 5 is the output of this function when x is equal to 4. So what do I get? E times a 1 times a 4 minus a d. So that is e times 4 minus d. That is 4e minus ED. I don't know why it's writing like that. D. Okay. So again, I don't know what E or D is, so I have to stop there. But I noticed that there's a relationship, right? I've got two unknowns. I'm missing the E and the D, and I've got two equations, one right there and one right there. So I can notice that this first equation tells me that ED is equal to minus 1. And if I use that in my second equation, this is telling me that 5 is equal to 4E minus ED. Well, this ED is equal to minus 1. Cool. So now I know that 5 is equal to 4E plus 1. Now E is the only thing that's missing. So I subtract 1 from both sides. I find that 4 is equal to 4 times E. E has to be 1. And now that I know what E is, I can figure out what D is. E is equal to 1 times D is equal to minus 1. D has to be minus 1. So let's find our original function. The function that we have, oops, not everything, was this. So I know that the function is equal to E times x minus 3 times x minus D. And we figured out what E was 1. We figured out what D was. It was minus 1. So our function is equal to x squared minus 3x plus an x, so minus 2x, and then minus a 3. This should do everything that was required of it. Let's see. Does the function at 0 give you a minus 3? Yes, right? If I look at this function right here and I plugged in zeros for all those x's, 0 minus 0, I'm left with a minus 3. So this is true. Let's look at our other point. 3 needs to go to 0. So does f of 3 give me a 0? So this would be 3 squared minus 2 times 3 minus 3. That's 9 minus 6 minus 3, or 9 minus 9. That is 0. So my second point is satisfied. Now let's make sure that 4 goes to 5. So 4 squared minus 2 times 4 minus 3 is 16 minus 8 minus 3. What is that going to give me? 16 minus 8 gives me an 8. 8 minus 3 does give me that 5. Cool beans. So this function is a quadratic, and it passes through those 3 points that I needed it to. Therefore, we've successfully completed the problem. That's the function that we're looking for. All right, hope you found this helpful.